In this lesson, we're going to focus on naming alcohols. So let's start with some basic examples. So what is the name of CH3OH? The common name for this molecule is methyl alcohol. It's also called methanol. Now what about this one? CH3CH2OH. The common name for this alcohol is ethyl alcohol. It's also known as ethanol. Now what about these two examples? What's the common name for this alcohol? So this is known as isopropyl alcohol. It has an isopropyl group attached to the OH group. And this is called tert-butyl alcohol. Now let's go over the IUPAC nomenclature for these two alcohols. So you can draw isopropyl alcohol like this if you want to. And so if we number it, this is going to be 1, 2, 3. So the OH group is on carbon 2, and we have a 3-carbon chain. So instead of saying propane, it's going to be propanol. It's going to have the suffix OL, and the OH group is on carbon 2, so this is called 2-propanol. Now let's focus on this example. So I'm going to redraw it like this. So we still have a 3-carbon chain, but now we have the OH group on carbon 2 and also a methyl on carbon 2. So this is going to be called 2-methyl-2-propanol. So that is the IUPAC name for tert-butyl alcohol. Try this example. Go ahead and name the alcohol. So we have to number it. And so the OH group is on carbon 2. And we have a 5-carbon chain, so instead of saying pentane, it's going to be pentanol, but particularly 2-pentanol because of this. Now, what if we have 2 hydroxyl groups? How can we name the molecule in this case? Now, for this example, it really doesn't matter in which direction we count, because no matter what direction we start from, we're going to get an OH group at carbon 3 and at carbon 4. So whenever you have 2 alcohols, it's known as a diol. So this is going to be 3,4-hexane because there's 6 carbons in the parent chain, and then it's going to be diol. So 3,4-hexane diol. Now let's move on to our next example. Go ahead and name the following molecule. So which group should we give priority? Is it the alkyl halide or the alcohol? The alcohol is the functional group that will contain the parent name, and it's going to have more priority than the bromine atom. So therefore, we need to start counting in this direction, starting from the alcohol. So this is carbon 1, 2, 3, 4, 5. So we have a 5-carbon alcohol, and so it's going to be called pentanol. And the OH group is on carbon 1, so it's 1-pentanol. And we have a bromine on carbon 4, so it's 4-bromo, 1-pentanol. Here's another example for you. So this time we're going to have 3 substituents. And it really doesn't matter which direction we start counting because the OH group will be on carbon 3. However, for these 2 substituents, it does matter. If we count it from left to right, we're going to get the name 2-bromo dash 4-chloro, and then the OH is on 3, so that's going to be 3-pentanol. Now let's say if we count it in the other direction. So I'm going to redraw this first. We still need to put the substituents in alphabetical order. So bromo will still come before chloro. Now this is going to be 4-bromo dash 2-chloro 3-pentanol. So which name is the correct IUPAC name for this molecule? Now the first substituent, if possible, you want it to be the lower number. So 2 is less than 4. So the first one wins. You want to try to put the numbers in ascending order after you alphabetize the substituents. So it's going to be 2-bromo, 4-chloro, 3-pentanol. Now what if you're given a condensed structure that looks like this? What would you do to name it? The first thing I would do is turn it into a line structure. So we have 4 carbons there, which I'm going to write it like this. And then on carbon 1, let's make this carbon 1, 2, 3, 4. On carbon 1, we have an OH group. And on carbon 4, we have a CH3O group. So now, how would you name it? So this is a methoxy group on carbon 4, and we have a hydroxy group on carbon 1. Whenever you have a hydroxy group and a methoxy group, this is going to take priority, and so this is going to be part of the parent name. Therefore, instead of saying butane, it's going to be butanol. And the OH group is on carbon 1, so it's 1-butanol. And we have a methoxy group on carbon 4, so it's 4-methoxy, 1-butanol. Now, what if we have an alcohol on a ring? How can we name this molecule? So we have a cyclopentane ring because there's a total of 5 carbon atoms, but we don't have to say 1 cyclopentanol. We don't really need to number it. We can simply say cyclopentanol because there's only 1 substituent on a ring, so it's automatically on carbon 1. Now, what if we have 2 substituents on a ring? So let's say we have an ethyl group and a hydroxy group. Now in this case, we need to number it. This is going to be 1, 2, 3, 4, 5, and 6. However, we don't have to say 1 cyclohexanol because the hydroxyl group is already part of the parent name and it's going to be on carbon 1. It's automatically assigned that position. So to name it, this is going to be 3-ethyl cyclohexanol. Now we do need to specify the 3 on the ethyl group because the ethyl group can be on carbon 2, it could be on 4, and so we need to say, hey, this is on 3. We need to give enough information that if we're given the name, we can draw this specific molecule. Now let's consider one more example with rings. Go ahead and name this compound. So automatically we know the OH is going to be on carbon 1. If we start counting this way, it's going to give us very high numbers. The methyl will be on 3 and the ethyl will be on 6. But if we count in the clockwise direction, the ethyl group will be on carbon 2 and the methyl group will be on carbon 5. So 2 and 5 is less than 3 and 6. So we want to count it in that direction. So to put it all together, it's going to be 2-ethyl, 5-methyl, cyclohexanol. And so that's it.